Okay, we are going to, for some reason I scribbled there, I'm going to do a video of these three problems since, Justin, you put them on the help board. I can't always do a video of all of them, but it takes me just about as long to do a video as to actually write them down anyway. So, here we go. This is like a private class. Hopefully others of you are watching this as well. We're going to complete the square in order to draw this. Now, in order to sketch a parabola, you can do it just by looking at the graph, the function, as long as it's in the form y equals a x minus h quantity squared plus k. If you can get your function into this form, you can just look at it and say, okay, I know what my vertex is. It's h, k. And then the points after that that you choose will be on either side of the axis of symmetry. The axis of symmetry is that middle line that goes down the center of the parabola. If we had a parabola, the axis of symmetry is that line that goes right down the center, and everything else is symmetrical. The axis of symmetry is the same as the h as h. The axis of symmetry would be x equals h. Remember, x equals is always a vertical line. We can also tell some other things by looking at the equation, the function when it's in this form. This a, if a is positive, then the parabola opens upward. If a is negative, the parabola opens downward, like that. So, another thing you can tell by looking at this is if you look at the number out here, that is the y-intercept. So just a couple things. This is not the y-intercept, this is the y-coordinate of the vertex. So the y-intercept is where it crosses the y-axis. And we're to do this by completing the square, and to complete the square you cannot have anything in front of the x squared term. So if you had a 2 there, 3, you have to factor it out before you begin completing the square. If this were equal to 0 and you're completing the square, you could just divide everything by that number, but since there's a y, we just have to factor it out. So we get y equals, now obviously the 6 is not going to be part of the perfect square trinomial because it's not perfect, so right away we're going to cast it out. So we're going to get x squared. If I take a negative from a negative, we're going to get plus 4x, and then we have to complete the square. This 6, we're going to take it out because it's not perfect, so it doesn't get to stay in the perfect square trinomial. So we complete the square, we say 4 divided by 2 is 2, and we square it, and we'll get 4. Now, we can't just add something onto the right side of the equation without either adding it onto the other side or subtracting it off of the same side. Now the thing is, this 4 is not really 4. This 4 is multiplied by the negative sign, so it's really negative 4. So we're really subtracting a 4 off, so we have to add it back on over here. Now we have a perfect square trinomial, and perfect square trinomials factor into something quantity squared, plus 10. Now we have it in this format right here. So we can look at it and determine the vertex is negative 2, 10. We know it's going to open downward because of that negative sign right there. And if we look up here at this is the y-intercept. So that's going to be the point 0, 6. It's going to give us our point. Remember, the y-intercept, it would be 0 and then straight up to 6. So now we can do ourselves a little sketch. So here we go. I can sketch it with just that information. So we get y, x, we get the vertex is negative 2, and this is a 10 up here. This is a sketch. Negative 2, 10, and it's going to cross, and our axis of symmetry is going to be x equals negative 2. So that would come the whole way down here. And then we get this point 0, 6 is our y-intercept. Once we have that point, we went 2 points to the right to get that point. So if we go 2 points to the left, 2 units to the left, we'll get our symmetrical point. Obviously mine's not that symmetrical. And then we just connect it, and we have our parabola. Obviously if you do this on graph paper, you'll get a better sketch. But you'll get an accurate sketch just with these 2 points and the axis of symmetry. Okay, let's try the next one. Sine of 30 equals 1/2. So you can replace the sine of 3 theta equals 1/2. You can replace the 3 theta with x. So we get sine of x, and then we'll put it back in, equals 1/2. This should be a familiar one to you. This is sine of 1/2. Remember, sine is y over hypotenuse. So if we did a little sketch here, the y would be this way, it would be 1, and the hypotenuse is 2. This would be the square root of 3. So we know that this is, from experience, a 30-degree angle. So we know that since that is our x, we can replace it there, so we get 3 theta equals 30 degrees. Now we need theta to be between 0 and 360. So if we divide this by 3, we get theta equals 10. Now we're going to need a lot of things, a lot of different degrees to get up to 360, starting at 10. The other place that we're going to get 30 is if we go, let's see, we're going to get another one at, hold on a second, this is number 13. We could do over this way. This would still be a positive 1. This is the square root of 3, and this is 2. This is still going to give us 1/2. And this angle here would be, this would still be 30. So this angle is going to be 150. So we're also going to get 150. And this one would just be 75. I mean, we're dividing by 3, sorry, so we're going to get 50. We have to go the whole way up. We're going to have to go around another time, so it's going to be 360 plus 30 is going to be 390. I'm just going to keep going. Then we're going to go 150 the whole way around, so we're going to add another 360, and we're going to get 510. 750, we go around another time, that would be 720 plus 30. And then another time, 870. The only way I know this is if I kept dividing these by 3, we would get 130, 170, 250, and 290. And that's, if we went any higher, this value would be bigger than 360. So that's how I know to stop. Really, you want to do, work these together. Find this one divided by 3, we're still in this range. Find this one divided by 3, we're still in the range. Just keep going simultaneously until you get a value that is under 360. If you did the next one, it would be bigger than 360. Alright, last problem. It's really noisy in here, I'm sorry. Okay. Let's see, I'll move over here. Okay, the last problem is, I forget which number it was, number 17. These are very tedious. So this one is tangent squared of 19 pi over 6 minus cosecant squared of pi over 2 plus secant squared of 3 pi. Okay, I like to convert these to degrees, but if you can get by without doing it, that would be great. So we get tangent squared, and if I took this times 180 and divide it by 6, I would get 570 degrees. Cosecant, this one's easy, because it would just be 90. And this would be secant squared, and it would be 3 times 180, which would be 540. Now we want to get these in the 360 range, so I'm going to subtract off 360 from these. So we're going to get 210, so this is going to be tangent squared of 210. This is going to be same cosecant squared of 90, and if I subtract off 360 from that one, we're going to get secant squared of 180. Now, I like to do a little graph. Some of you can already do this in your head, but I'll just do the graph. We're going to get 210, so if we draw 210, it's going to end up being, here's 180, 210 will be down here. This is really rough the way I'm doing it, so this would leave us with 30. This is 1, 2, square root of 3. Tangent is opposite over adjacent, so it would be 1 over the square root of 3 squared. Cosecant is the inverse of sine, so we know sine of any number is going to be y over hypotenuse, so the cosecant is going to be hypotenuse over y. So let's draw a little sketch. I think I ran out of room here. So it's 90, so it's going to be right here, and the point of this is going to be 0, 1. The hypotenuse is this part right here, so it's going to be hypotenuse over y, and y is 1, so it's going to be 1 over 1 squared. For secant, it's the opposite of sine, so sine of theta is x, oops, this is cosine. Cosine of theta is x over hypotenuse. And if I did the secant, it's going to be hypotenuse over x. So if I do another little sketch for this one, it's too messy, it's too small for that. It's 180, so it's going to be right here. Its point would be -1, 0. Its cosecant would be hypotenuse, which is this right here, 1, over x, which is -1. And that is squared. So now we have our simple equation. We're going to get 1 square root of 3 squared is just 1/3. -1, and then 1 squared is going to be 1. -1 squared is 1, so your answer comes out to be 1/3. So that's it for those three problems.